Hello world, welcome back. Today we're going to be talking about solving exponential and logarithmic equations without a calculator. The next lesson will be using a calculator. So mainly we're just going to talk about just using some of our log properties and exponential properties to manipulate equations so that we can get them into a solvable state. All right, let's get to it. So the properties that you would use if you're going to solve an exponential or logarithmic equation would involve either the one-to-one properties or using inverse properties. Today, our primary focus is, since we're not using a calculator, we're going to focus on both of these one-to-one properties. Sometimes I like to call them the obvious properties because if a to the x is equal to a to the y, x would have to equal y. And then likewise, if log base a of x equals log base a of y, then x would also have to equal y. That's the only way that would occur. All right, the inverse properties we can talk about in the next lesson. So first set of problems, solving simple exponential equations. So here we go. Look at this first one right here. 2 to the x equals 32. So they're saying 2 to what power is equal to 32? So some of you already know the answer to this. You might want to look it up. You get just 2 times 2 times 2 times 2. So since a big giveaway that this will have a nice integer or rational answer is the fact that they're not asking you to use a calculator. All right, so 32 is 2 to the 5th power. So we can rewrite this equation as 2 to the x equals 2 to the 5th. Now we can use that one-to-one property. That means that x has to equal 5. So the next one is slightly more difficult, but it uses the same idea. So you can't use that one-to-one property unless your bases are the same. So we have to get both sides of this equation to have the same base. Now, both 4 and 8 share something in common. Like 8 is not a power of 4, but both 8 and 4 are both powers of 2, right? So we can substitute in the base 2 equivalent of 4 and 8 and then use properties. So what I mean by that is 4 is 2 squared. So I'm going to replace 4 here with 2 squared to the 3x power. I'm going to do the same with 8. 8 is the same thing as 2 cubed, and that's going to be to the x plus 1 power. Now, when you have an exponent raised to an exponent, you multiply. So we have 2, and I'm going to just change colors on this just for fun. 2 to the 2 times 3x, 6x, just really emphasize those exponents, equals 2 to the, now I'm going to throw a parenthesis around that x plus 1. So it's going to be 2 to the 3 times quantity x plus 1. In a moment we can distribute that 3, but the main thing is that those two exponents that I've color-coded in black on both sides of the equation, we know that they have to be equal to each other because of the one-to-one property. So 2 to the a is equal to the b if a is equal to b, blah, blah, blah. All right, so let's isolate now. We're going to say 6x equals 3 times x plus 1. I'm going to divide both sides by 3. And then we have 2x equals x plus 1. Subtract x from both sides, x equals 1. And just for fun, we could go back to the original and plug in 1. So we have 4 to the thirds equals 8 squared. So is 4 cubed equal to 8 squared? Basically, is 4 cubed equal to 64? What is 4 cubed?
4 raised to the 3rd power is...
Okay, 64. So we know we did it right. All right, we have one more simple one. So 3 to the what power equals 324. So why don't you just pause the video here and see if you can get this one. So I believe that, I'm pretty sure that that 3 to the fourth power. So let's just double check on that with our calculator here. 3 to the, I think it's going to be the fifth power as I'm thinking. Yeah, 3 to the fifth power. So this is 3 to the x equals 3 to the fifth. Therefore, x equals 5. Done. Okay, so now, those are the more simple ones. They can definitely get more difficult. But it all just involves just condensing and just utilizing exponential properties. So they're just basically testing your knowledge of algebra. Okay, so look at this first one here. So we have an exponential variable. This is an exponential equation. So I really want to condense those variable expressions into one exponent to start. So since 9 is the base for both of those exponential expressions, we can bring them together. So when you're multiplying like bases, you add the exponents, right? So this is going to become 9 to the negative 3x plus x, right? And that equals 27. So negative 3x and then plus regular x is just going to be 9 to the negative 2x equals 27. Now this has just become a problem like that last one where you, since 27 is not a power of 9, we know it's a multiple, but it's not a power. So we need to see if there's a way to express both 9 and 27 with a like base. And there is, that's 3. So we can replace 9 with 3 squared, and that's to the negative 2x. And that's going to equal 3 to the third power. So it's important that we, let me just fix this to the third power. It's important that we combine our exponents on the left side of that equation, and then we can utilize that one-to-one property again. So this is just going to become, let me just shrink this down. I wrote too big. Of course that would happen, right? Yeah, nice. And so we have 3 to the negative 4. Negative 4x equals 3 cubed. So that means that we have negative 4x equals 3. X equals negative 3 fourths. And there you have it. You can double check on that if you go back to the original. If you were to plug in negative 3 fourths, it's going to be 9 to the negative 3 times negative 3 fourths times 9 to the negative 3 fourths. And we would hope that that equals 27. So this is going to be 9 to the positive 9 fourths times 9 to the negative 3 fourths. And then we can add those exponents together. So you get 9 to the 6 fourths, which equals 9 to the 3 halves. And that's 9 to the 1.5 power. And if we go back to our calculator, clear all, 9 to the 1.5. Where's my decimal? There it is. That's equal to 27. Okay. That's how you check your answer. I don't want to bore you with doing that every time, but I would advise that you do that moving on. Next problem. Okay. Once you pause the video and try to do this on your own, you got to maybe first check to see if 9 is in fact, or 243 is a power of 9. You could get everything in terms of base 3, but I have a feeling that maybe 9 to the third power might be that. So I'm going to go use my handwriting calculator. I think that's better for this activity. 9 to the third. Nope. I I'm wrong. So yes, we need to get it to base 3. Okay, so yeah, let's go ahead and do this. So 3 to the 5th power to the k plus 2 times 3 squared to the 2k minus 1, just put parentheses around there, equals 3 squared. Okay. So before we do anything, we need to get our bases to be alike. So this is 3 to the, distribute that 5k plus 2, plus 10. And we have times 3 to the 4k minus 2 equals 3 squared. Okay, and then we're gonna add our exponents together. So we're gonna have 3 to the 5k plus 4k, which would be 9k, and then plus 8, because 10 and negative 2, and that's going to equal 3 squared. Now we have a simple algebra equation, and that's just going to be 9k plus 8 equals 2, 9k equals negative 6, and then we know that means k equals negative 6 ninths, or negative 2 thirds. Again, I would plug that answer back in to make sure it's right, but I'm feeling fairly confident that it is. Another hard example, I'd like you to pause the video and do this one and then check back in. All right, so 16 is, I think, again, you could get everything in terms of base 4 if you're really feeling creative, but I think just going to base 2 is probably the safest way to go about this problem. So I'm going to take that 16 over here and replace it with 2 to the 4th power to the 2p minus 3 times 2 squared to the negative 2p equals 2 to the 4th. And then we're going to apply exponents. So we end up with 2 times 2 to the, and this one is going to be 8p minus 12. And the other one is going to be negative 4p. Remember, because we're multiplying with like bases, we're going to add those exponents together. And of course, that equals 2 to the 4th. So when we add these exponents together, we're going to end up with 2 to the 4p. 4p minus 12 equals 2 to the 4th. And then we go ahead and just have a simple equation. We can just say that 4p, that means that 4p minus 12 equals 4, 4p equals 16, and then we know that p would have to equal 4. P equals 4. Lovely. Okay, so that is a fair amount of examples for solving exponential equations, again, without the use of a calculator. I think there's a couple good takeaways from that. The main thing is you really get to practice just those old exponential properties. Now let's talk about log equations. If you flip back up to the beginning again, we had that one-to-one property. So there's a couple things that we know about logs. We know how to convert it to exponential form, and also we know this one-to-one property. Okay, so the one-to-one property is fairly obvious. So let's try a couple simple ones, and we'll do a couple difficult ones, and we'll call it a day. So here, since this is equal to 0, it's easy enough to move that ln3 to the other side of the equation. So we end up with lnx equals ln3, because I added ln3 to both sides. And because we can because we have like bases on both sides and that's all that's there, we're allowed to set their arguments equal to each other by virtue of them having that one-to-one property. So this is going to be x equals 3. Done. Moving on. Now this next one's a little bit more difficult because there is not a log on the other side of the equation, so I can't use that one-to-one property. So when in doubt, you need to ask yourself, you have to say, all right, can't do that. Maybe I should just convert this to exponential form and then see what happens. So yeah, if this is going to be equal to, we'll have 3x plus 1. It's funny. 3x plus 1 equals 5 squared, exponential form. And then 3x plus 1 equals 25. 3x equals 24, x equals 8. Now, one thing that I haven't talked to you about just because we barely started talking about log equations, you know how I said to back substitute, make sure your answer is correct, just check your answer. You should always do that in algebra anyway when you're solving. It's even more important with a logarithmic equation. You take that answer that you get and you plug it back into the original the way it's stated, right from the beginning, okay? And the reason you have to do that is because sometimes you end up with extraneous solutions for log equations. So you just have to keep that in mind. It doesn't happen all the time where there's an extraneous solution, but there are certain circumstances that pretty much result from that power property, if you remember that. It's similar to squaring both sides or whatever. So yeah, it can generate extraneous solutions. And the reason you know it's extraneous is because the domain for a log function is that a basic log function is x has to be greater than 0, or in this particular instance, you just look at the argument, and if you plug in a value here that would make that argument negative, then we know that it's not valid. Okay. I would pause the video and do this one. So this one's pretty straightforward. Again, log base 3 on both sides, so I could just go ahead and take 5x minus 1 and make it equal to x plus 7. Solve, it's going to be minus x plus 1 plus 1. So we have 4, x equals 8, x equals 2. Go look back at the original. That's going to be 9. So yeah, it works out. Lovely. Okay. And 2 more examples. These are slightly more difficult. I feel like the log ones don't get as nutty as the exponential. But so when you look at this one, you notice how there's a 2 on the other side. I can't just move that log over, right? So that they're equal to each other. So again, if you're really, really good with your log properties, you could solve this a myriad of ways. But I think the easiest thing to do here is condense whatever logs you can, just make them a single log. So here we could use that that product property for logarithms. So since we have like bases, we have base 10, and they're being added, we actually could multiply their arguments and create a single log that way. So I'm going to say log of 5x times the quantity x minus 1, and just for fun, I'm going to put a bigger parenthesis around that, is equal to 2. And then what that means is that I can convert this to exponential form, and I end up with 5x times quantity x minus 1 equals 10 squared. So yeah, and then you could take it from there. Before I go ahead and distribute that 5x, I'm going to actually divide both sides of the equation by 5, because I'm going to change 10 squared into 100, right? And then divide by 5. So when I divide both sides by 5, that's going to drastically simplify what we have to do. So we have x times quantity x minus 1 equals 20. So I have x squared minus x. I'm going to bring that 20 to the other side. Minus 20 equals 0. Let's factor x 4, 5, negative, positive. All right, so x equals negative 4 and positive 5. Like I said, go back to the original, sub both of those in. So if I plug in negative 4, what happens? That's a problem. I end up with log of negative 20 plus log of negative 5, you can't take the log of a negative number. So you see how I circled my answer? Right away I know that negative 4 is extraneous. So now let's plug 5 in, positive 5, and you get log of 25 plus log of 4, blah, 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 and it will work out. So actually there's only one answer to this one, even though we thought that there were two. So perfect example of why you'd want to back substitute and check your answer. Last thing, ln of 4x plus 1 minus ln 3 is equal to 5. Pause the video, try this out. Condense, hint, okay. All right, welcome back. We're going to go ln of 4x plus 1 divided by 3 equals 5. ln is log base 3, so we're going to convert this to exponential form. So we have 4x plus 1 divided by 3 equals e to the 5th power. And here, again, I don't have a calculator, so I wasn't asked to write this as a decimal. We're just going to have to write our answer in terms of e, and that's fine. That's completely fine. So I'm going to multiply both sides by 3. I get 4x plus 1 equals e to the 5th times 3 times e to the 5th power. Subtract 1, so we have 4x equals 3e to the 5th minus 1. Then we divide both sides by 4. So our final answer is going to be x equals 3e to the 5th power minus 1, all divided by 4. See, that's how I did that, just divided by 4 over here. All right. And that's it. Hopefully that was helpful. Again, these videos are a little bit longer than like a 5-minute, here are a couple simple examples. I'm hoping that this, was good for you to be able to go through and see slightly more sophisticated answers, and, maybe you were able to even brush up on your exponential and logarithmic properties. All right, take care. See you in the next video.